things about this. It will be, it'll be massaged before it becomes the final minutes. And also, it's not a bad idea to kind of like screen scrape capture it once in a while, because every once in a while the Etherpad has a hiccup.
Every now and then, my own company faces, text editable, events, or your choices, because we had issues where like suddenly types that's not like through.
Yeah, yeah. And that's never good.
This is stupidly obvious. Putting the agenda and hitting the pad, it's a really great.
Thank you. That's,
I've never seen anyone do it before, but it's completely obvious.
I always screen scrape the agenda and use that to build my own notes, which is what I did in what I sent to you yesterday. Incidentally, Warren, could you monitor Jabber? Well,
Probably.
all right, that'd be great if you could. It should be right off the tools page, I think. Yeah. Okay. So we're going to get going, folks. Good morning. This is the benchmarking methodology working group, and I'm Al Morton. Thank you for working so hard to find this location. It's one of the more difficult rooms to find in the London metropole. I hope you all brought your coats, because occasionally it gets really cold in these dungeon rooms. So you may need some help with that. Has anyone not signed the blue sheets? Yes, all right. Sort of keep this among the floor here, and I'll ask that question again, trying to pick up as many names as possible. Okay. Thank you. All right. So as I mentioned, this is the Etherpad where we're going to collectively create our meeting minutes. I've got two folks, Pierre and Karsten, who are going to be primarily in charge of that. But anyone who phrases a question at the microphone and would like to be sure that their name is spelled correctly, and would like to be sure that the phrasing of their question is exactly what they want, feel free to type it on the Etherpad. Thank you. Also, it helps actually, what I'll do right up here at the top, it helps to say that Al is this purple color. So if I type anything in, that way folks know what I have pasted. Other folks can do that as well. So there's Pierre going in. See, this, it works just like magic. Great. And here's Karsten. Fantastic. All right. So here we go. We also have currently 7 participants on Meetecho, and they can see the slides, but they will only be able to hear you if you speak directly into a microphone. So when we're conversing in general in the room to make it more possible for these folks to participate, please join us at the microphone. And of course, the little sign up there says to say your name when you're about to make a contribution to the IETF. All right. All right. So this is our meeting at IETF 101. As I said, I'm Al Morton. Sarah Banks is intending to join us remotely today. She was unable to travel here, but we will see her, I suppose, shortly, and you'll certainly hear her participating as we go. I have the suggestion to move close to the front because we're usually a small crowd, but feel free to sit wherever you want. If you're not subscribed to the Bmwg mailing list and you would like to be, there's a nice link there in the slides that you can download from the agenda or from any other place of interest. Okay. Next slide. So here's our note well, which is why I asked you to sit up front. This is our IPR considerations. Basically, every contribution, that's speaking at the microphone, document, hallway conversations. Certain hallway conversations are also covered, but they're covered by our IPR policy. What we ask is that you disclose any IPR in connection with those comments in a timely fashion. And actually, the truth is now everyone who's registered has read this, because you have to click that you acknowledge it when you register for the IETF. So this is mostly a reminder. And if you're unfamiliar with any of these best current practices documents, then that would be a good thing to take a look at as well. So here's our agenda for today. As I mentioned, we have 2 note takers, but everyone in the room can participate on that. Pierre and Karsten, thank you. We have a Jabber Scribe. I think, is your Jabber Scribe machine not working yet?
It'll be working soon.
Oh, it'll be working soon. All right. Warren Kamari, our AD advisor, area director advisor, sitting up front here. And he's playing both the important role of AD advisor and Jabber Scribe. Thank you, Warren. So I've just mentioned the intellectual property rights statement, and the blue sheets where we all sign in on attendance. That's all moving around. Oh, and that's got to stop. Oh, that's not going to be good. All right. I think it's just on the other side. It's on the other side of the wall. They've basically got to turn that down somehow.
Yeah. Wait, in case.
Yeah.
Yeah, no, it is definitely on the other side.
All right. Okay. So here's our planned agenda. We're going to do the working group status and the charter and the milestones briefly. Hopefully, assuming Sarah joins us, we'll have a quick status of the SDN controller benchmark drafts. If not, I can provide that. And then Sudin Jacob is with us, and he's going to be presenting the EVPN and PBB EVPN draft, updates to that. Then we have a whole list of continuing proposals here, for which some of the authors may not join us. So we may be able to move through some of this fairly quickly. I'm thinking perhaps item 5 may be one of those quick ones where I'll give a brief status. So it's network service layer abstract model, back-to-back frame benchmark, updates to the firewall benchmarking for modern firewalls, return of the VNF benchmarking methodology, and considerations for benchmarking network platform, virtualization platforms. The last 2 items are working group discussion. We have a ETSI NFV liaison on NFV benchmarking, a normative specification. We're going to take a look at that. And our last item is to sort of close on the topic of rechartering the working group. We've circulated charter text. We've circulated charter milestones. Let's finish that up and move it on to the next stage of approval. Any questions about the agenda? Any bashing needed? Does anybody need a drink of water? That's good. All right. So let's say that we've closed on the agenda, and let's move right along to the quick working group status. So we've completed IETF last call on the revised SDN controller drafts. And there's two, terminology and methodology. That's how we've traditionally split our work here in the benchmarking methodology work group. We got quite a few comments during last call, and the authors have revised those drafts. They are now on the agenda for the April Mumble, first week of April, I believe, IESG meeting. So that means we'll probably get some more comments from ADs shortly, and hopefully that will all go smoothly and we'll get those approved in short order. So we had an interim meeting. That was back in February, last week of February, I believe, or first day of March. I think it was March 1st. And that's where we really saw in some detail the new proposal for benchmarking modern firewalls. Had a real chance to go through that specification there, and had some good comments on it. There's been updates, so we'll be talking about that again today. And then our status is really that the proposals keep coming. As you saw on the agenda, all of these are now active proposals. So we will consider those and milestones for them as we consider rechartering. Any questions on the working group status? At least this part of it. This is sort of part one. Because we have no new RFCs this time, but that's not bad because at the last meeting we announced about 6. So we've been making really good progress. We'll update the charter as soon as we can. And we do have this nice supplementary working group page, which has been moved now to one of Sarah's administrated websites. So we have that available. If you want a quick heads up or getting started guide to joining the working group, this is the place to find it. I wrote this up some time ago, and it's still fairly valid. All the links are good. So let me ask the question: who is new to benchmarking methodology working group? Who's attending our session for the first time? Everyone's a repeater. That's great. Very good. All right. Well, welcome back then, everyone. So that, I think that concludes the working group status except for the milestones. And here's our status on milestones. Basically, they're all done, which is why we're rechartering. We don't have to talk about any of them being late, which is good news. So, so we'll have a new set of milestones, and hopefully that'll be part of our discussion at the end of today. All right. So we always have this quick discussion about a standard paragraph, which I have developed some time ago and like to see incorporated in our drafts. The reason for that is this, that we have a scope which is laboratory testing only, isolated test environment. And for years, folks in the security directorate or other directorates would look at what we were doing and just absolutely flip out. And you can't send traffic like this over the network. And they had never read our charter. The scope of our charter for lab-only testing was, not generally included in the drafts because we all knew what we were talking about. And so we sort of jointly developed this paragraph for the introduction and/or security considerations sections. And you're welcome to modify this or to use it wholesale if it applies to your work. And we've effectively reduced the amount of difficulties that the directorate reviewers who've never been in the room with us have with this kind of thing. So just a word to the wise. That is available. All right, let's see here. So this is our work proposal summary matrix. And I think what I'm going to do is bring this up again when we get to the new work. But let's go back to the agenda and begin to pick it up from there. So I think, let's see here. Now we don't have Sarah, and we do have Bala now. That's good. Okay, so I can sort of see who's joining us, and so can you, in fact. So great. So we don't have Sarah. We don't have Bhuvan, who generally speak about the SDN controller performance. But I've already given a brief status on that. If either one of them joins us, we'll reinsert that in the agenda where we need to. Okay, so then moving on to the next topic here is that topic would be the benchmarking methodology for EVPN and PBB EVPN, and our presenter is going to be Sudhin Jacob. So let's get to the point where Sudhin is in the queue, and I will bring up Sudhin's slides, which are here. And we'll go to presentation mode on those. Okay. And Sudhin, can you join us and speak?
Hear me? Can you hear me?
Yes, we can hear you now. Thank you.
Yeah, hi. Hi, Al. Hi. Good morning, everyone. So this is the draft which I'm going to present as a benchmarking of EVPN and PBB EVPN services. So which is both become the RFCs in best work group. Can we move to the next slide?
It's I've moved, but it's I see it's still coming on MeetEcho there. So hang on.
Okay. Thank you, Al.
So actually, we can see it here in the room, Sudhin.
Okay, fine. Then I'll read from my slide. So the comments which was received from the previous IETF 99 and the offline comments which were in the mail exchanges. So they require the clarity in the topology, then terminology sections, and certain sections has to be moved out of the draft. And one important comment was received was ESI withdrawal, that is the flushing of MACs in the local Ethernet segment. That has to be especially earmarked, and the removal of the type pi route. So all these sections are taken care, and we have modified based on all the comments, which these are the highlights of the comments, and all the sub comments we have incorporated the draft. So then moving to the next slide.
Yeah, we're there.
Yeah, perfect. Thank you. So these are all the high level, the benchmarking parameters we have defined for this services. That is the MAC learning, the MAC flush, the MAC aging, the high availability, the ARP and ND scaling, scale, convergence, and the SOAK. So based on 8 parameters, these are the 8 parameters we defined to benchmark these services, EVPN and PBB EVPN services.
Okay.
And yeah, they're going to.
I've moved to slide 4, Sudhin.
Oh, thank you, Al. So special thanks to Sarah for guiding us, and she was very helpful in giving the comments and the total outlook of the draft. And thank you all for the valuable feedback who all given in the IETF 99 and offline comments. I really value that and really appreciate that. And thanks, Al, for the support.
You're very welcome. I'll mention at this point, Sudhin, that I've been trying to recruit some folks who are able to provide some additional support in the form of perhaps some suggestions for additional tests and things of that nature. Does that sound good?
Yeah, sounds good, Al. I mean, because anyway, we are working for the community and always welcome.
Very good. Okay. Well, are there any questions for Sudin on the benchmarking of Ethernet virtual private networks and provider backbone Ethernet provider virtual private networks? It's a mouthful. Seems not.
Okay, so
All right. Very good. Well, then thanks for updating the drafts again this time, Sudin. And I think your last slide basically says next steps, request for adoption. So I think we're like we're basically three quarters toward adopting this draft. I mean, on the summary of proposals, I've already got this one marked green, and I don't think there's going to be much argument about adding a milestone with respect to this draft. So I think that I think you're sort of well on your way to adoption, and let's just look for further suggestions on development and bring them in as soon as we can.
Thank you, Al. Thanks a lot for the support. Thanks, community, for the support.
Very good. I've got your thank you slide up right now too, so that's a perfect time. All right.
Thank you. Thank you. Good day.
All right. Thank you, Sudin.
Yeah. Bye.
All right. So then back to the agenda. So now we're going to look at the continuing proposals. And unfortunately, slide item number 5 is one that we don't have a presentation for this time, but I'm going to give a quick status, and that is that so this is the NSLAM, Network Service Layer Abstract Model. So we had a presentation on this remotely in the Singapore meeting, the IETF 100. The interesting part of this proposal was that it attempted to model the service layer in a way that it could be tested, and the current model was more for control of a BGP router. So what we've challenged the author to do is to make this modeling effort more specific to benchmarking, and so that is something he's working on. And he corresponded with me by email, basically to say that the work's in progress, and he's expecting to complete the draft this month with this benchmarking example built in. And so we're looking forward to that, but at the moment we're kind of on hold, waiting for update. So I'm just mentioning in my quick notes here, benchmarking example will come in. Okay. So then then now we're up to item 6. Which is a proposal from your chairman, Al Morton, to update the RFC 2544 back-to-back frame benchmark. So let me bring that deck of slides up here. That's up at the top. Okay. All right. Welcome, gentlemen. Please find and sign the blue sheet. Someone's got it for you right behind you. Very good. So we have this draft on sort of updating the RFC 2544 back-to-back frame benchmark. And let's take a look at that. So 2444 specifies this benchmark, It's defined in RFC 1242 as the longest burst of frames that a device under test can process without loss. So tests of this parameter are intended to determine the extent of data buffering in the device. Now, once we learned that intent and also the test that was involved, we've got, with some further investigation, we found ways in which we could actually improve sort of getting at this quoted sentence. And I'll describe that briefly. But one other thing that we noticed is that in RFC 2544, there's an extremely concise wording of the objective, very concise procedure, and very concise reporting. And by concise, I mean brief, and perhaps at some point it would be worthwhile to add some additional detail. So that's another thing that this draft does. So let's go down here. All right. So at the Singapore meeting, let me actually, I'm going to skip ahead here just a little bit. We ran some tests recently using the back-to-back frame benchmark. And what we noted was that for some fixed frame sizes, the testing was extremely consistent. And what that means is that the length of the burst that could be accommodated without loss was fairly stable in terms of repeated tests. Also, we noticed that with some frame sizes, it was highly variable. And there was a reason for that. Which I'll get to if we have more time. But essentially, anytime that the device under test was almost able to accommodate the frame rate at a given frame size chosen, then you would see basically no buffering in the device, or no ability for a burst of packets to exceed the buffer size, because packet header processing was fast enough that that packets were moving through. There may have been some buffer developed there, but it simply was not possible to overflow the buffers on a regular basis. Every once in a while, you might see something. That was generally the cause of inconsistency. So some of the test equipment reported frame lengths which were extremely long, unexpectedly long, but that turned out to be just a limit of the test equipment. It would send a 30-second frame of packets, and they would all pass through because they were at a fairly high frame size, and therefore a low packet header rate. And the header handling rate of the device under test was sufficient to handle those packets. So you basically couldn't create a loss. And the device test device would send a maximum burst of 30 seconds, and then it would report the maximum burst size without loss is 30 seconds. Well, we all know none of our devices under test have 30 seconds of buffering. So this needs to be noted and added to the procedure. So it was also noted that calculating the extent of the buffer time in the DUT helped to explain the results for all these frame sizes. And that's the corrective calculation that we're basically proposing here. And it was observed that the actual buffer time could be estimated once you had calculated a throughput prerequisite test. You could tell whether frames in the device whether frames would be just passed through the device under test, or whether they would be buffered. And if they were buffered, then you could actually measure the buffer, the total buffer size. If they weren't, if they were just passing through the device under test, then there was no way to do that in this testing regime. And I've basically got a slide which attempts to show that, although it's just too small for most of you to see. But I can explain it briefly. We've got different packet sizes here: 64 bytes, 128, 256, up to 1518. And the most important bar here is the green bar, which is the maximum theoretical frame rate for the device under test with its interfaces and so forth. And we had a test with a couple of different V-switches. The OVS V-switch is in blue, and the VPP V-switch, vector packet processing, is in red. And we see throughput in frames per second, so that's the y-axis here. And with 64-byte frames, we could not attain the maximum throughput. That's not all that surprising. It's very common with the smallest frame sizes. And so at this frame size, we were able to very accurately estimate the buffer size, because now that here the packet header processing was less than the theoretical maximum throughput of back-to-back frames. And so we always saw some burst length which had some loss in it. Now here, we're sort of right on the 128-byte frames. We're kind of right on the cusp of the maximum theoretical. So here we saw some variation, but that's completely explainable. Sometimes it would handle the burst, sometimes it wouldn't. There would be some variation in the results. By the time we get to 256-byte frames, their throughput is equal to the maximum theoretical. So now the packet frame processing rate of the device under test is preventing the buffers from growing. So this is the effect that we felt was really important to be able to handle and actually to cover as part of the test procedure. So what we're recommending then is this prerequisite test of the 2544 throughput. Any questions so far? Does who in here has run the 2544 back-to-back frame throughput test? One, Doug. Thank you. So that's good. Well, I'm not gonna go through this procedure then in detail, but you've basically you can basically see what's happening here. We always start out with a list of fixed frame sizes. The tests are composed of repeated trials where we're searching to find the largest burst length that the device under test can handle without loss. For each frame size, the trial requires sending a burst length and counting the forwarded frames to be sure that none of them have been lost. And we're seeking the longest burst length with zero loss. We've got a test. The test outcome is the burst length for each. After the searching, you have found the longest burst that you can send without loss. And then we repeat the test n times with the searching, and the burst lengths with zero loss are then subsequently averaged, and the average length is the benchmark over n tests. So, well, let me talk about the updates now. Now we've got a little bit of background here. So we've basically clarified text describing what is measured when we report this length and the corrected burst length. I'll talk more about that in a minute, but let's just stare at this for a moment. Knowledge of the approximate buffer storage size in time or bytes may be useful to estimate whether frame losses will occur if device under test forwarding is temporarily suspended in a production environment due to unexpected interruption of frame processing. And then this parenthetical, an interruption of duration greater than the estimated buffer would certainly cause lost frames. Now, you can't really estimate what the minimum in practice what the guaranteed number of frames that could be accommodated during a short interruption of forwarding. You can't really guarantee that because you really don't know the state of the buffers when forwarding is interrupted. And the truth is that all the buffers could be almost full when forwarding is interrupted briefly, and that would cause the sort of the additional burst or the short interruption time to be 0. So actually, always 0 is the minimum. But so now we've at least kind of got this range that we can characterize with this test. So this is the potential benefit of essentially using this correction factor. And there's lots of detail in terms of background in these two references. So what we've basically got here is a presentation from last summer at the Open Platform for NFV Summit, and that's where some of these tests were analyzed in detail. And we've also got a wiki that supported that testing, which explains the calculations in even more detail than the slides in this presentation. So I think for the sake of time, I'll let you read the draft, go over the calculations yourselves. But effectively, with this, when you have the implied buffer time, it's the average number of back-to-back frames that you can send in a burst divided by the maximum theoretical frame rate for the interfaces that you're using. So that's the implied buffer time, the length of the burst divided by the rate at which the burst is sent. But when we want to correct that, what we need to recognize is that with packet header processing in progress, many of the packets that have been sent into the device under test have been processed and passed out of the device by the time the burst eventually causes a loss. So what we try to do is estimate that by using the theoretical, well, actually the ratio of the measured RFC 2544 throughput, the maximum offered load that the device can handle. We use that to correct this implied buffer time. And so what we're effectively doing is estimating the number of frames which have passed through the device in the burst. And that way, what's left is the frames that have been buffered before we see the tail drop loss. So that's basically the calculation. We're going to report that as by frame size. We're going to report the frame length. We'll have the min and the max and the standard deviation of the repeated trials, and then this calculation of the corrected buffer time in seconds. So that all of that will be part of the reporting for this metric, and obviously these parameters. Static and configuration, number of test repetitions, the minimum step size in deciding on the burst, and so forth. So, any questions about that material? Okay. Well then, so this is the most interesting part. I wanted to get to the point where we have a little discussion here. When we're searching for a burst size, should we include a particular search algorithm here? Should we? My guess is that we should always start from a burst length which we're fairly sure that the device under test can accommodate, and that way that burst will show 0 loss, and then we can begin to step up in a linear fashion to reach the burst size which possesses a loss. So. That's my thought on the on one search algorithm, but there could be others. So I'm looking for input from the group. Any ideas there? Well, then let's consider this other one because it's also related to searching. So should the search include trial repetition whenever a frame loss is observed? To potentially avoid the effects of background loss. With virtualized devices under test, virtualized switches and so forth, every once in a while you have sort of this unexpected mode of operation where some extremely important background process has to be handled, like file system flush or something that's completely non-maskable, and you have to have it, but it could end up unfortunately influencing your test results. So I think that it would be worthwhile to immediately verify when we see a frame loss, whether that loss occurs in a reliable way at a given burst length. So we have a comment.
So Carsten from IETF, Carsten wasn't. So I think I would like to pose the question the other way around: how to get to a realistic measurement result if only testing at a given time? Because these kind of things that happen from time to time in virtualized systems, we see them as well, but sometimes they happen only once an hour. And yeah, I'm not sure what is the intention of this methodology. Should it actually yield the optimum result, or a realistic result, or the minimum result?
Well, if the phenomenon that causes the occasional once an hour loss is not the phenomenon we're trying to measure, the capacity of the buffers in the device, then it would be really good if we could somehow separate those two effects. And one way to do that is to perform long-term testing, let's say at the throughput level, and to look at the results every 5 minutes during the hour, and then to find out how often some background process causes loss and influences the results.
Right, but then you have to do a lot of repetitions in the end.
Yes.
Like a real large number of
Yes.
repetitions.
Yes.
Or alternatively state just simply like, do everything possible to make sure that there are no background processes happening. Flush the file system before,
Right.
Make sure all of the interrupts have been cleared. I don't know what could be done.
No, that's, if you can legitimately kill demons that would not necessarily be running or something, truly unnecessary background processes. I think that would probably be a legitimate thing to do. But then some of these other things just are like file system flush. They have to be lived with. So then your point is, let's encourage those to happen before the test, just like we've done in the past with making sure all the ARP all the Mac learning is done before a test takes place, so that maintenance and administrative kinds of things have occurred outside of the testing interval.
Well, if you give me a 2-socket system, I would challenge that I can get very different results if the virtual machine is running on the first socket or on the second socket, because some interrupts cannot be moved away from the first socket. So yeah, I'm not sure, if the results should be really well reproducible, then it takes a lot of effort to define the environment and to make sure people are not circumventing it.
Yeah, that's true. That's true. So I think that the draft currently encourages people to, in general, to operate this test under circumstances that appear to be, the kind of test environment we've been able to count on in the physical world, where if you see unexpected loss, you troubleshoot your environment and try to scare that stuff out. I agree it's going to be much more difficult to do that here now, but I think we should still encourage that. And so anyway, I think that's, I mean, I think we've had a good discussion about the sort of the trade-offs here of adding this repeated trial aspect. And let's think about that some more, and then see what we can agree on when it comes to some text. I'll probably propose something coming out of this meeting. Rather than attempt to do it here. Okay. Well, let's see. So as far as next steps go, I'd like folks to take a look at this. It's not that long a draft. We could create a milestone for this work. That's actually part of the proposal for the rechartering. We're hoping, at least I'm hoping, for a working group adoption for this draft. We can't ask anything about that today because who's read the draft, by the way? Anybody? No. Okay. So we can't ask that question again today. But I really encourage folks to read it. And but we could still propose a milestone if folks are interested in this topic. And this is one of the ones that I think where we can probably really learn a lot about the environment that we're focusing on, this virtualized testing environment through benchmarking like this. So I guess that's it. Any further questions or comments on this topic? No? Okay. Well, good. Thanks for your attention. And we'll move on to the next thing. All right. So let's see here. I'll kill this one. So back to the agenda. So now we've got item number 7, which is updates to the firewall benchmarking for modern firewalls draft. Karsten's going to be our presenter. And let me get those slides up for you, Karsten. So let's see, where is it? There we go. I'll bring this version of it up. All right. And you're all ready to stand in the box. That's great. Let me give you the let me give you this and make sure it's working. Yep, it's working. Okay. Very good.
Okay, so actually my colleague Balaraja has done most of the work, but he can't be here today because of another project. So I'm the co-author. So we've worked together with a group of people called the NetSec Open Group to create this next-gen firewall performance benchmarking methodology document. Has anybody attended the interim meeting 2 weeks ago? Okay, cool. Thanks. So I don't want to spend too much time, but there's some background about this group that has been formed, and it's outside IETF, but we decided to that we would really like to contribute our test plans to the IETF Bmwg. So the idea is to have new methodology, a benchmarking methodology and terminology for next-gen security devices, firewalls, but not only firewalls, basically all of the network security solutions out there today, like IDS, intrusion detection, unified threat management, web application firewalls, and all sorts of other beasts. And of course, there is pre-existent RFC for firewall security, firewall benchmarking, testing, but that's about 10 years old now. And we really want to strongly improve the applicability for today's solutions. And we also want to improve the reproducibility and transparency of these kind of tests, because the old RFC was like they used to do. They provided some guidelines. The question is how do people interpret these guidelines in the same way, and like two labs would come to the same conclusion. So one of the ideas and requirements for our work is also that multiple labs come to the same conclusion. And as a footnote, in the end, we want to create a certification program about this. So just a quick walkthrough of the draft. Currently, we're in version 02. Version 03 is ready, but I didn't want to upload it last minute, so it will be uploaded after this meeting. And so basically, introduction, scope, and so on, like normal. There is a pretty extensive section on the test setup, test bed configuration, how to make sure the test beds are all configured in the same way, some guidelines for the DOT configuration, for test equipment configuration as well. And then a section called test bed considerations, how to make sure that things become reproducible, that everybody has the same kind of test bed setup. Section 6 is reporting guidelines, basically definitions of the key performance indicators. And we found that even basic things like I don't know, throughput or something like that is always an interesting question, like how do you define basic KPIs? So we wanted to define those. And then in section 7, we currently have 10 ideas for detailed test scenarios. So each of these test cases is like multiple pages of description and starts with the basics that you could find also in the old RC 3511, right?
Right.
Yes. And but it moves much beyond the details, much beyond with the details provided. And we put a lot of effort specifically on SSL HTTPS testing, the test cases 7 through 10. And I think that's where we see the whole internet going. There is probably in a few years from now no unencrypted HTTP traffic anymore. So firewalls need to be tested specifically with SSL, TLS, HTTPS in mind. So the test setup is kind of as expected. There is a solution under test or a device under test. In the middle, there can be some aggregation switches, aggregation routers if the test equipment needs them. And the test equipment is expected to emulate clients and servers on both sides and routers if needed from the configuration perspective of the DOT. So far, nothing, no surprises. The surprises come rather when we talk about like what do we actually need to test and what's actually in scope. And because of the wide variety of different solutions that exist out there, there is no single set of test methodology that can be applied to everybody anymore. And also the amount of tests required to test more, to validate more advanced solutions are growing explosively. So we looked at what kind of test areas there could be, like on the left-hand side, basic things like web filtering, antivirus, SSL inspection. It's actually not the basic things. It's like starting with more advanced things. And we looked at, what can we actually provide? And of course, that would become a very long document in the end. So we said we're going to focus on a certain subset of test methodology for now that we can actually manage. And of course, any contributions are welcome, both in this leftmost column area, which is like the initial scope from the point of view of the current authors, and also in the future scope. So as much as we can get done, of course, we'd be happy, but we wanted to confine our scope to things that we can do ourselves from the existing set of contributors. So next-gen firewall future scope would be web filtering, what was this? Data loss prevention, DDoS, distributed denial of service, certificate validation. And these are all functions that are implemented today, but they are not implemented by everybody. And so we thought we focus on that in the future. And then there are all of these other security functions, which we haven't started discussing: next-gen intrusion prevention service, web application firewall, breach prevention systems, SSL brokers, and I forgot again what AD was. So there are lots of different functions, and the matrix is still open and ready to be filled as soon as we can get some contributors for that. So the KPI definitions that we have so far is on some basic things like on the TCP, on the HTTP layer, and things like time to last byte, time to first byte. And actually, it turns out people have a good understanding about time to first byte, but we already started to having some discussions about time to last byte. And that's just one example. So time to last byte, just to give you some insight, means like how long does it take to deliver the whole HTTP response or HTTPS response, all of the content back. And in most cases, people have only looked at how long does it take for the first byte to arrive. And then the assumption was, well, the rest will just trickle through the line somehow. But I think that's not what we see all the time. And so time to last byte is also interesting. But then discussions come in, this depends on the size of the request and response. And some people, the vendors always like to create responses that are only 1 byte large because that improves the performance of the device. But on the other hand, of course, the operators want to have realistic sizes. And the test labs sometimes want to have very large response sizes. So these are the kind of discussions we've been having in the last few months. We basically started discussing this around a year ago, and we started the detailed test plan discussions. Ryan would know better, but he's listening, I think 6, 7, 8 months ago. So I'd like to just walk you through one of the test cases as an example. There's 7.1 throughput performance with a traffic mix. And so the first question is, what do we want to do here? We just want to determine the average throughput performance of the next-gen firewall. And that test case has already been in 3511. So what's the difference here? First, we define a specific application traffic mix. So it's not a uniform stream of frames or packets that's coming in with arbitrary content or no content. In fact, these are all HTTP, HTTPS requests, which follow a certain distribution of URLs, of certificates, and so on. And that has been well defined. Then there are a couple of variable test parameters that the user can choose, like how many clients they want to have, how many servers they want to have, what's the traffic distribution between v4 and v6. I think defining something statically here would be unwise because v6 traffic is growing over the years and we'll have to adapt to the reality. And also the initial and target throughput. So let's say we start with 10% of line rate, and then the target throughput would be 100% line rate, and we need to see what is the actual performance of the solution. And so that requires some binary search in that case. So we start in the test procedure to run with 10%, for example, then go to 100%, and then go through a binary search. So that's much like many other Bmwg RFCs have worked this out before. And so to understand what is the actual throughput of the system, we have to define a maximum failed application transaction rate. Currently, it's set to 0.01%. So every 10,000 requests may fail. All the other 9,999 are expected to succeed. And we also defined what is the maximum number of sessions that might be dropped unexpectedly by the DUT. This is unexpected TCP reset percentages, and what's the maximum deviation of the time to last byte. So let's say, for example, a firewall would actually run through all of this requests successfully, but would have wildly differing latencies because maybe it gets out of it gets lost with in which sequence to process the requests. And then, of course, the time to last byte would be so much differing that it doesn't actually make sense to use the device anymore for this kind of load. So that's why we want to limit the TTLB deviation. So let's say that the difference between the maximum and the minimum time to last byte shall not exceed a certain threshold. And in the same way, also the maximum TCP connect time is controlled in this test case. So let's say the device gets loaded, and then it takes more and more and more time to actually start responding in any way. So it takes time to connect new TCP sessions. That's sometimes a way for a device to manage very high load, but of course at some point it becomes unreasonable. And again, we felt we need to limit the maximum TCP connect time.
May I ask a question?
Please.
Al Morton asking a question as a participant. But when we say binary search,
Mhm.
do we all know what we mean when we say that? Do we all know that we're starting high or starting low? Do we all know that there's a step size involved, no matter how you search? I'm thinking that there's, and I see Warren nodding. I see a possibility for us in one of our works to define this with a little more specificity. Do you have any thoughts on that?
Yeah, I think we're defining this in the draft. If not to the level of detail that you think is reasonable, then we can certainly expand the definition. It's not a big deal. I think there is no magic behind binary search.
No.
It's just a question of definition to make sure everybody uses it in the same way.
Right. And then, I'm sort of thinking that this repetition of checking certain results, that it would be important to have that, if we agree that that's a valuable thing at some point, that it would be easy to see how we would build that into binary searches and linear searches and so forth, if we have the good degree of specificity.
What do you mean with repetition?
Well, like I mentioned before, if you get a result in the data plane testing, if you get a result with loss, run that test again and now see if it's still roughly the same level of loss or
Yes.
now suddenly clear.
The problem with that is that binary search is a very time-consuming method. So let's say we need 10 iterations to get to the precision of 0.01 percent failed transaction rate or what? No, actually, no, that's not the point. I don't actually know what precision we defined here. But I remember for 1% precision, an average of like 7 iterations are required, unless, of course, the device is just passing the initial maximum rate with no loss at all, in which case it's only 1 iteration or 2 iterations, initial and target. But if that's not the case, then around 7 iterations are required. Let's assume each of those runs 2 minutes, then we already have 15 minutes. But normally you want to run the test cases a little longer. So if you have half an hour, and then if you want to repeat the whole series of tests multiple times, it easily becomes days of testing, just waiting for results.
Yeah.
Sometimes a little difficult in the lab.
Sure.
So I'm actually open if anybody has better ideas than binary search. We once tried linear search in some situations where the results were very difficult to predict. But of course, with linear search, you immediately have many more iterations from the start.
So I guess my thought about that is the test of the past should be able to help us fine-tune the parameters for the searches of the future, and that there's basically always some correlation between results across tests that test the same configuration, and there might be a way that we can improve test time. I mean, test time is always one of our big constraints. If we build that fact into the repetition and by kind of tightening the search range based on previous results, that might help. I don't know if you may have already tried things like that.
Well, I'm certainly open for suggestions.
Sure.
And we haven't always tried out everything because we are bound to what test equipment can do, right? So
Right.
if we have to do everything manual, it doesn't make sense. So typically you program some iteration method, and that's depending on what the commercial test equipment out there supports.
Yeah. So the good news is that we have some folks from the commercial test equipment world usually right joining us or watching our lists very closely, and when we decide that we need something with a lot of motivation and they agree on the value, then we'll influence what's available to us.
Yep, I'm pretty sure, and Ixia and Spirent are both contributing to this effort.
Yes, very good. So another question I had or comment, Karsten, is this phrase "test results acceptance criteria." We had to be really careful with the wording on this, because we've always said that our benchmarking and really any performance measurement in the IETF, that we don't declare kind of like a pass-fail criteria. We seldom set performance objectives here in a numerical way. We may recognize that they exist, but the IETF itself hasn't standardized them. We allow others to say, here's the target rate, and then you use the IETF procedure to find out whether you've met that or not. I mean, we at the same time, we've always had a kind of acceptance criteria. RFC 2544 throughput is run with 0 loss, and that's a numerical sort of acceptance threshold or target objective for the test that you're running. And this is additional dimensions which have the same. I mean, they have the same feel, but I think we've got to be careful about how we word these, and it may be that we ask the testers to provide the 0.01% themselves, or maybe suggest this set of criteria has been used in an appendix, something like that.
Well, I always thought from the beginning of my career that the 0 loss in RFC 2544 was a strong and very helpful statement. And over the last few years, we've jointly suffered from, vendors trying to deviate from this 0 loss in the virtual world, and the subsequent attempts to standardize any non-zero loss.
Right.
So I think there is great interest in these numbers, and I don't want to shy away from them. If we completely remove these targets from the draft, I think it would lose a lot of its value, because we really want to set like expectations, minimum expectations for next-gen network security devices. Now, I understand also, of course, that it's one of the more difficult decisions to come to a specific
Number. Yeah.
So maybe we can move them into an annex or something. But I would personally prefer very much to keep the numbers in the document.
Yes.
Because I think without that, it's just another thing that can be tweaked per each user's preferences.
Yeah, and if there's complete freedom here, that's not achieving the goal of let's avoid speckmanship and have comparable results from every test from every lab. So we've got to we have to somehow balance the desire for reproducibility with our aversion here to setting acceptance criteria. And one of the ways we can do that is to get rid of the words acceptance criteria.
Okay. I see.
So, but let's work this aspect. I appreciate your bringing this topic for discussion. Thanks.
Yeah, and admittedly, there is still a lot of wording to be improved and aligned with normal IETF Bmwg wording. So we're open for those comments.
Yeah. No, this is a great start. Thank you.
One way to make sure that the numbers, if any, here are representative and realistic is also to bring in some users. And we have this set of calls, weekly calls, that are aside from Bmwg calls. They're basically just working calls.
Right.
And currently we're bringing in some users from financial sector, mobile service provider, mobile operator, and automotive sector. So like just some users, enterprise and service provider, to make sure that we actually fulfill their requirements.
That's fantastic. And somehow we need to, in some way include these participants directly in Bmwg work if we can. Maybe there's the opportunity for an interim meeting in the future where sort of jointly Bmwg and NetSec Open get together with some of their industry participants, because I mean, just yesterday in the operations directorate group, we talked about how do we get more user input and to make our specifications more relevant, and this is right on point. if you guys are able to, if NetSec Open is able to help us do that, great. Let's go for it.
Okay, sure, we're happy to. So it goes on with the other test cases, and I don't want to bother you with more test case discussions here. So in 7.2, concurrent TCP connection capacity with HTTP traffic. It's a similar, question, how to get to a good description. And we also defined some things here like the HTTP object size and the rate at which this capacity test has to be conducted to make sure it's actually realistic. One of the main motivations of this whole work has been that the data sheets of firewall vendors have shown less and less connection to the reality of the actual throughput of their devices in real life scenarios. And one of the reasons was that this test case, for example, is typically carried out with zero traffic. So basically the vendors just open the session and maybe send a request to get 1 byte response in the beginning, but then they leave the session open and they change the timeout so that the sessions are kept open, and then sessions sit there, and it's basically just only a memory game. How much memory can I put in my firewall, and how long does it take to fill that memory? But and then usually we came in as an independent test lab, and we try to reproduce this. It doesn't work because, of course, we keep sending requests over all of these connections, or at least a subset, and often these connections are dysfunctional. So the device is completely overloaded and it doesn't know what to do anymore. It has no capacity to process packets anymore. It's only busy opening more and more and more connections. And that's what we wanted to get away from and make sure that this the result from this test case yields a realistic number of maximum connections. So I spoke about the traffic mix before, and one of the test equipment vendors involved in this work has contributed a traffic mix that they prepared since October, for around a year. And so they basically defined a modern enterprise parameter traffic mix. We already had this discussed in the interim meeting, and I remember Sarah and you and some others saying, yeah, this is wonderful. Please, not specifically this distribution, but in general the idea, please let's add more traffic mixes for other scenarios, because an enterprise parameter is important, but it's not the only traffic mix. And for example, a mobile operator one would look very different. So this is a blend currently of 70% encrypted, 30% unencrypted traffic. There are a lot of different URLs, and the exact URLs probably don't matter because they change all the time anyway. If we would look at the exact Office 365 URLs, probably Microsoft has changed them 3 times since this was generated. But what is important is that the certificates don't change at the same frequency, and that the type of traffic distribution, like how many connections does a client open to actually get to Office to use Office 365, that also doesn't change so frequently. And the number of URLs used in this parameter mix also doesn't change so frequently. So there's always a few heavy applications and a long tail, and these are quite important to use to create a more realistic scenario again. So there are 10,000 unique URLs, 1,000 domain names, 400 certificates, and this makes sure that the firewall cannot be optimized. The configuration cannot be optimized by a vendor just to say like, okay, let's dump all this memory, let's reduce our certification store to 1 and just send all the same certification again and again, buffer it and cache it, and then optimize our throughput. So we really want to have a realistic results, and that's one of the means to getting there. So this traffic mix is already implemented in at least 1 emulator, and I think another vendor's getting up to speed, and we're also trying to see how we can actually implement this mix in an open source emulator, the T-Rex emulator, which would then just be a capture and replay. I'm not sure how this is possible with the certificates, but we'll see. So that's basically all I wanted to say about the content. Proposed schedule, I promised to upload. Oh, so I think I actually made a mistake. So this should be draft 02 and 03, 4, 5, 6, 7. So I need to fix this. So I have an offset of 1 in this draft numbers. So draft 02 has been uploaded before the deadline, and draft 03 will be uploaded tomorrow. The traffic mix annex has been added and 2 more test cases. And subsequently, I think we want to proceed quickly. And an important milestone would be in June to add security effectiveness sections. So far we only focus on benchmarking, but of course to test those more advanced security devices, especially intrusion prevention, intrusion detection, of course there's no point of testing the throughput. The important point is to test different types of attack vectors. And there is a NIST database which we're looking into, probably having around 1,000 attacks that we want to test. And we won't define them all in the document, but we'll probably point to the NIST database and select some.
That's a great, that's going to be a great benefit. Definitely reference that. And, you know, we should all look it over and help to choose the ones that you target.
Right. And then separately, we are running some proof of concept testing with a couple of solutions we will be running, let's put it that way, especially for the performance benchmarking test cases. Those POCs are scheduled to be completed end of June. And then hopefully in July and before the deadline for Montreal for 102, we'll have a stable draft to be submitted. Now, question back to you, because I'm not too familiar with the whole process. It's like, how do we get to an RFC and what are the steps I need to observe?
Well, so it would be really good if we adopted our charter within the next 2 weeks. I mean, I think we can make steps toward doing that and get some milestones agreed. And then, assuming Warren can successfully negotiate the new charter with the IESG, which hasn't been a problem since 1989, then you know, we'll be in full go-ahead mode. Now, with this schedule, trying to get a stable draft by July, we're basically looking at trying to get interim meetings together to advance this work as quickly as possible. And I mean, if that's what you're asking, and that's what the working group is ready to do, then we could probably get pretty close to July. I think that's a little bit on the demanding side, but I can also imagine that if you want to get it done before all the summer vacations start, I can understand it, because then you're looking at 2 months of not much happening.
No, I want to get it done because we want to get it done because we think there's some urgency, and specifically because we want to use the results for certification within the NetSec Open Group. So we're progressing the work anyway. And if an interim meeting is as easy as like a 1-hour conference call like we staged 2 weeks ago, I think we can even use the existing calls and just, you know, give one of the calls, or, you know, from time to time a call under your guidance and Sarah's guidance, and actually make them IETF interim meetings.
Well, I think I suspect that that's possible, as long as we obey the, you know, sort of our meeting announcement, sort of pre-announcement rules, things of that nature, and as long as it's accessible to everyone in the IETF, and we publish the minutes and so forth, all the usual interim meeting stuff, then we're probably good to go on that. I think it's probably reasonable to maybe have let's say working group consensus by July, if we have multiple interim meetings and so forth. I mean, then there's our area director review, which has gone quickly and smoothly for good drafts. and then there's the IETF last call, which takes about 2 or 3 weeks, and then another couple of weeks to get it on IESG agenda. So I think by the time you're looking at IESG, our governing body approval, we're probably looking at sometime in August for those steps to take place. But folks in NetSec Open can say this achieved a consensus in the working group, and it's moving through the approval process. If we achieve working group consensus by July.
Okay. That sounds great. And I mean, of course, we're a bit selfish in terms of the two reasons we are actually putting this work in the IETF is one, of course, we think it will be much better recognized in industry, and we think if we spend a whole lot of work creating a good test plan, then makes sense to give it to the best, organization in industry that's seen, that's recognized not only by the service provider world, but also by enterprises. And the second is, of course, that we want to benefit from the whole process and experience and, making sure this is actually technically a good standard.
So in fact, when it comes to July, we have another face-to-face meeting scheduled in July. That's in Montreal.
Yeah.
It's probably going to be easily accessible to a lot of the NetSec Open folks. Could travel there for the day or whatever. And so that might be a good time to put the finishing touches on the working group consensus aspect for whatever group of tests you're able to put together by then, and then take it from there.
Right. Okay. So request for action, please review, and please feel free to contribute. On each of the sections, we have assigned contributors for these the test case list that I explained before, and in addition, specifically new traffic mixes, contributions are requested, and security effectiveness test methods.
Okay.
And if anybody is interested, then we're more than happy to invite you guys to the weekly calls that we have. We actually have 2 weekly calls, one on performance benchmarking, one on security effectiveness. That's it.
Very cool. Any questions, folks, or comments? Looks like a pretty organized effort to me. I think I thank you for bringing it here. I mean, not only is it going to help you, it's going to help our visibility in this industry as well. I think we should plan on 2 things. We should plan on getting a security area advisor, someone who is sort of willing to look over this from the security directorate, like for an early review or things of that nature, just so that we have the benefit of IETF's security expertise right from the start, because that's basically what we're talking about, the intersection of benchmarking and security.
Right. So the OPSEC group has asked me to present this draft.
Great.
Which I will do, I think, tomorrow or Thursday. Not sure. Tomorrow, I think.
That's good. That's good. I'm really glad to hear that.
And by the way, I shouldn't forget thanking for the other people who are attending. So Erika and Tim from UNH are participating in the effort. And if you have anything nice to say about organization, that's actually Brian Monkman's work here. He's the director of the whole NetSec Open effort.
Very good. Very good. I'm glad some new folks from NetSec Open have joined us for this. That's great. Is there a problem?
Just checking, sorry. Just go on, go ahead.
Okay. All right. Well, when we get to the charter, we'll see that, I've obviously recognized this as a very active draft, and so we have a milestone proposed for this. We may need to revise that milestone, though. So based on your most recent version of this work fast interim meeting schedule. So we'll try to remember to do that when we get there. All right, let me drop this. Let's see, end that slideshow. All right, we can get out of that. All right, very good. So now let's see here. We've got. I've already got this one up. That's good. So I think our let me make sure. I think our next topic is this one with Raphael. Is that correct, Raphael? Yes, absolutely. All right. So let me see what I can do with this. I think that's about as big as I can make it.
Okay,
So Raphael, welcome back.
thank you. So you go slide by slide, or how do you prefer? You go.
I'm sorry, I didn't understand the question.
Can we go like I talk to you like next slide and or
Oh,
there's
yeah. Well, I don't think this will work because it's a PDF.
It does actually work.
Oh, it does? All right, all right.
Let's try.
Yeah, sort of. Well, don't worry, I'll true it up after you press it.
All right. Thank you.
Good.
So basically, this is a work done by some research background. I'm going to tell the storyline about this. It's about VNF benchmarking methodology, and mostly I'm here to talk what we know so far that we came to this draft, and answer these 4 questions here along the presentation. So basically what we know so far about benchmarking VNFs in our concepts from the research. I'm doing research in university, benchmarking VNFs. We know that there are different concepts for VNF, since the definition of a runtime like P4 program until different ways of compiling VNFs, optimizing, modifying the state, and then the data plane of the VNF. There are different decompositions of the VNF itself, like Project Clearwater, and some of VNFs are truly programmable via SDN concepts and openly switched. We know that also there are different motivations for benchmarking VNFs from different actors like VNF developers, service provider, infrastructure providers. To compare VNFs with physical network functions, to know the footprint of VNFs, and to have some analytical development of VNFs as well. We know that there are different factors that VNF depends on, the performance of the VNF. Basically, it's all the blocks here with the green config blocks. We have done tests to evaluate that. And this is basically the storyline. I started this work in 2015, like proposing a paper and some ideas how would benchmark VNFs as a service. Then we went to NFVRG, then we went to Bmwg, and then we had a stop over there that we are quite naive at that time to make progress with the draft. We see that still the considerations for benchmarking that became the RFC 8172 were still being performed here. So we took our time, we developed some code, we ran experiments, we came with publications, and now we are back here to see how the group is open to receive this work again. And we have open source to be released this year too. So our contributions for the group here are basically on the running code that we have done, our experience, and the RFCs that we published. So mostly the draft was updated because it was not focused on methodology itself in the beginning. So there was a comprehensive rewriting done based on experiences in the running code that we developed. We have the target for this draft is actually to build kind of like a solid foundation for VNF benchmarking methodology itself as a generic framework. And we think that specific VNF benchmarking methodologies could be derived from this document. We aim to approach like publications that we are performing, and we see in the literature. There are other groups also interested in this that we have been exchanging emails with, and mostly activities also inside ETSI and FV. The scope of the document basically considers VNFs as black box and defines methodology for them. But this is something that we need to discuss as well, because as I showed you in the beginning, there are many VNFs that are open source and are open for instrumentation, internal instrumentation. So we think now and this is open for discussion in the group, I think, we consider white box approaches as a particular case with some proper considerations of internal VNF instrumentation. This is something that we need to discuss. The terminology base comes from ETC framework. It's also inside the draft itself. Most of the reference there. We come with also reference to RFC 1242 and RFC 8172. We don't have any other references of NFV, I think, inside IETF, so we need to grab most of these definitions of VNF from ETC. This is something also that it's open for discussion. And so, which were the major technical changes from this draft to the past is that we realized that we have different ways of testing VNFs. We come from dimensioning, verification, and benchmarking, as ETC pretesting working group did. And we know that at the end, some of them both of them close to benchmarking. We have a generic VNF benchmarking setup specified in the draft that with generic components. I'm going to show it. We have the definition of what is a deployment scenario and influencing aspects of the VNF performance itself to be considered. So what we consider as a generic benchmarking setup is that we have all these components. Basically, it's a coordinator interfacing agents that are sending active probes to the system under test, composed of execution environment and a VNF, and where possible monitor components can be deployed inside the execution environment and also the VNF. Not all of these components are mandatory in a test, and we consider that also these components can be aggregated in only a single white or black box. And we consider also that, described it in draft, that all the possibilities of these components influence the performance of the VNF itself and the test. For the general description of the draft, we consider the definition of two terms to make it generic enough for other VNF benchmarking methodologies. A VNF benchmarking layout. It's the structural and the function definition of parameters that compose the test setup that is going to define the method of benchmarking the VNF. And the VNF performance profile is basically the extracted metrics that associate the target metrics that are extracted from the VNF after the test, correlated with the benchmarking layout. Ideally, we see that with the benchmarking layout specification and the configuration definitions that are also specified in the draft, it's possible for a user or any other person that has the skeleton of hardware and software components deploy these tests, and it's possible to reproduce all the deployment scenario and repeat the experiments defined by them. The procedures itself, they're defined in the draft. It's just an initial proposal. We have a lot of work to do in that. We are seeing from the work done so far here in Bmwg how we can specify more and more details about the procedures. So we didn't come with an orthodox proposal for procedures. We're more open-minded to see how the community thinks about it. But basically, it goes for the deployment until the extraction of the features step by step. And the testing procedures, I think this terminology here is aligned with the liaison proposal of let's see, we have a trial that's basically one iteration to extract a singular measurement from the VNF benchmarking metrics. We have a test that defines particular components to define these trials. So one test can define multiple trials. And we have a method that is basically a set of parameters that can compose a range of parameters for multiple configurations and define various tests. And we consider that we must define particular cases as defined in the RFC 8172 and methodologies for those cases as well. Currently, there are just specified some considerations that we must take in for these cases, for the noise behavior, what each component in the generic setup would take actions for, how it would react, how the metrics would be influenced by that. And we think that an additional item here would be a white box VNF particular case, where possible considerations of internal VNF instrumentation might be defined. Considering the VNF benchmarking report, I think it's important here to specify, we don't have a particular, I think people in the research, people in the academia are very interested in seeing a report format of metrics, how would it be defined. But from our perspective, we just understand that the benchmarking report for VNF would consider the structure and the function parameters that were defined in the benchmarking layout. We also define that it must aim the statistical significance of the trials and iteration of over many tests, as was defined by all in the back-to-back draft. In virtualization scenarios, we don't have strict boundaries of the VNF. We don't have strict boundaries with the execution environment. There are different behaviors, like one change in a line of code can change the whole iteration of how the VNF works. So we need to repeat experiments many times. So we aim to see statistics in different ways defined in these reports. We are actually looking how we could pose some metrics, like definition of possible metrics, and even the specification of outliers into this report. This is a research that is being done. And we think that also the performance profile must be associated with the 3x3 matrix coverage by the Bmwg. So we have an open source reference implementation for that. There are two publications. The first one is the definition of the framework itself. The PDF contain, this presentation contains links for the papers. And the first one defines how this framework called GIM was defined, coded, and the design principles as defined there. We aim to have a way of specifying a framework that is lightweight, that we can have comparable metrics, repeatable experiments, and can be fully configurable to execute experiments. So we think this framework can be a reference implementation that realizes that this VNF benchmarking methodologies in the document. Currently, I'm reviewing the code. We got because this was developed in a partnership with a company, and we got the open source approval to release the code open source. So now I'm documenting and refactoring the code to release it. And we think it will be released by the second half of this year. So the idea is that the draft and the open source code walk side by side. This is, I think, one of the interests in the working group as well, and the IETF. And we have a lot of work to do. We know that. We came here as a open-minded view of what is a VNF benchmarking methodology. We have open source running. We have reference implementation for that we consider it. We think the draft can be a common ground for VNF benchmarking methodologies. The list of things that we need to do are much bigger than what we have done. And basically, I think we need to refine the scope to see if we consider white box VNFs as well. I think this is something that we need to discuss. We need to assert the terminology, considering if the draft is considering a proper terminology or taking most of it from the ETC NFV. We consider also exemplifying the benchmarking procedures and parameters, or maybe referencing the open source code, or maybe itself in the draft as generic format. We are going to explain, that's for sure, explain each particular case as a subsection, defining the objectives, the procedures, and the possible reporting format for that. And also the definitions of the report We are doing research just to see what's the best approach to have a report format or not, how it would be built. We need to adjust the draft with our in conformance of RFC 2119 to define what are the musts, the cans, the shoulds of it, and possibly we think that in the future we can have a liaison statement to ETNFV for this approach. So I think this is all, and we would like to see your comments, suggestions, critics. We are more than welcome to have them. Thank you all.
Thank you, Raphael. Before we start with the questions, let me ask, where are the blue sheet? Where is the blue sheet? Has anyone not signed the blue sheet? There's a gentleman in the back there, right? Good, okay. So that's good. Have to keep track of that administrative thing. All right, so let me open the floor to questions for Raphael. Anybody had a chance to read the draft or any of the publications? Well, I took a look at one of your publications, Raphael, and I'll quickly try to get back to that here. Let's see. Probably easiest. Did I go by it already? Yes. So I looked at taking the open vSwitch to the gym. And thank you. And I saw, we didn't get to this level of detail today, but I saw a few places where I think some of the models, if you will, for the descriptions of parameters and so forth, there were frame sizes associated with one of the models for the vSwitch, for example. And I thought to myself, the frame sizes are really a traffic generator parameter, and in fact, the vSwitch. The vSwitch should be surprised by the frame sizes that are in use. It shouldn't have any configuration that relates to that. So just as a general comment for folks who haven't read your draft or the publications, I think that there may be some opportunities to kind of better coordinate what parameters are used with each entity in your test setup. And also I thought it was kind of interesting that this is about VNF benchmarking, but strictly speaking, the virtual switch is part of the infrastructure, and the VNFs sit above that in a typical ETSI diagram, right? So in that way, it's a good place to start, but don't expect to keep being able to benchmark vSwitches with
yes, yes. I totally agree. And the thing about putting open vSwitch there is like this second publication was more of testing the automation of the framework itself of the gym, the source code, and right. How the perspectives of automating the benchmarking tests. I know open vSwitch is, as you said, is used mostly as an infrastructure element. We know that there are certain possible ways of using open vSwitch also as a part of a VNF itself, as one of the early definitions of what is a VNF, one of those projects, and considering the parameter definitions, I agree. It was just an initial proposal. We are actually, it's one of the ideas of the framework is to make it fully configurable. So the configuration of the frame, for example, the frame sizes were mostly for the agent part of the framework, how it would express the infrastructure, and later on have a reference to get that, and as a result and correlate that in a database. I can show you the how it works. Later we can.
Let's plan to get together one-on-one, and we'll talk about some of those details.
Yeah, we have a proposal of a demo late this year. Probably we're trying to put it at SIGCOM, but I can show you the code and how it's run. Yeah.
Great.
I'm finishing a PhD thesis, so I'm short on time to make this code happen, like by the end of the year.
Hi, Pierre Lynch. I haven't read it yet. I haven't caught up. This has been around for a little while, and I'd seen it a year or two ago, I think, but I'll catch up, I promise. But just two things. You're so involved in doing open source with this. Have you considered working with OPNFV? They're a pretty good testing outfit for stuff like this, and I know they're looking into VNF testing, and they'd be interested in this as a project. So first thing. Second thing, any liaison to IETF test working group will get attention, I guarantee you.
Okay. For the first one about OPNFV, when we were developing when I was developing the source code, I checked all the projects inside, like Yardstick and vSwitchPerf. And what I saw is that there was even another framework called TOD for automation of tests. And what I saw is that I could make it happen through OPNFV, but I saw it mostly attached somehow with OpenStack, and the orchestration and configuration were kind of like quite attached with each other. So in this framework, I tried to make the configuration of the benchmarking setup itself totally independent from the orchestration of the elements and the setup of the environment. That's one of the reasons I put it outside of OPNFV. I see totally the initial proposal of the code was to be a benchmarking as a service. So it provides interface APIs that an orchestration or any OPNFV testing function could make use of it. This is the main target of the source code as well. And for the liaison, yeah, we're open-minded for any ideas.
Okay. All right. Well, I think what we'd want to do is sort of get a good understanding of the work in your draft. That means getting people in the community to review it. And then we'll consider sort of writing a liaison to ETSI on this specific topic. We've got later in the agenda a response to ETSI that we would need to consider here, and that's it's a slightly different thing, but we might be able to put the two together. I don't know. We'll see.
Yeah.
Just for efficiency.
So one more question. What kind of open source code have you published, and are you planning to publish?
The open source code is not published yet. It's going to be published by the second half of this year, and it's a full framework developed in Python. The first publication here, I can show you later. It's how the framework is defined, the specifications, the design issues, and how we benchmark it VIMS of Project Clearwater. So yeah, it's stable. It's there are many components inside, and the idea is that we have generic ways of interfacing probers in the way that tools that stress and send the stimulus for the VNF, the traffic stimulus, in most generic way possible. And we extract those metrics, and we feel that correlated with the structural definition of the benchmarking setup. And we are using now Elasticsearch and then Kibana for visualization of the tools of the metrics. And then, yeah, and all the messages, it's totally, every component is a microservice. The idea is that we have all the messages as REST, we have REST APIs and full flexible messages among the components, programmable messages. Yeah, and I'm happy to share the code as soon as possible, but and also to explain it and share the publications.
So you mentioned OPNFV before. Does the code depend on any OPNFV
No,
project?
no, the code is fully independent.
Okay, cool, thanks.
And so I think I understood you to say, Raphael, that when you saw heavy reliance on OpenStack in projects like Yardstick and OPNFV, that was kind of a that was kind of a negative for you guys. You wanted to do the management yourselves and control and configuration yourselves. So that kind of puts it in the same class of project as vSwitch project at OPNFV. And but I think that's interesting. That sort of aligns it with Test 001 as well, where just some mechanism was imagined, over on the management side that would put the VNFs together and set them up ready for characterization. So that's interesting. You're basically taking that management role away from OpenStack, but that allows you to get very explicitly what you want from the system.
Yeah, we consider benchmarking VNFs, for example, deployed using Kubernetes, OpenStack, and any network virtualization platform that might be available.
Very good. Very good. So we have another question.
Yes,
Please, sir.
IETF, it's Wang It's what is the BNF? That is your page. There is a P4 runtime API. It's kind of library things. But is it you think about the BNF also?
Yeah.
Yeah, part of also the some function with this API is also the VNF. And separately, this only thing is also the VNF. You think that?
That's good. The P4 runtime API is like just an example. I have colleagues working with developing basically a compiler, a P4 compiler, and they're working also with implementation use case for that. And I have a colleague, for example, working to develop to make a broadband network gateway, where you have multiple VNFs inside the VNF itself, with, let's say, VNF components. And I think this is truly possible. The idea was just to put an example, what a VNF can be, how a VNF can be abstracted. And we are seeing this closer now to this programmable, packet programmable independent protocol pipelines like before. And the idea is that we are also having benchmarking scenarios with P4, like say VNF like P4, defined by P4 programs. And now we see that this can be changed at runtime. I mean, the pipelines themselves. So this exemplifies as a VNF can be abstracted and how we can consider it inside the draft itself.
Okay. All right. Any more questions? I guess not. Well, thanks very much, Raphael, for this excellent presentation.
Thank you.
Much appreciated. Let's see, let's get rid of that. And now we're back to this. And so I don't see Samuel on the list, but a list of remote participants, but he's got a draft on benchmarking network virtualization platforms. It kind of follows on from the work that Jacob Rapp, who's his co-author, did on data center benchmarking. That was with Lucian Amarov and some others. So I encourage people to take a look at that. We're not going to hear about it today. And I'm going to quickly bash the agenda here. My inkling is that the most important of these next two topics is rechartering Bmwg. We'll get to the liaison after we go through that. But my thought is that we probably ought to consider the rechartering discussion like right now. So let's do that. Let's see. So where is the charter text? I think it may be, oh boy, this is going to be a challenge, isn't it? Wait a minute, wait a minute. Let's see if it's this one. Does this have the milestones? Yes, this has the milestones. All right, I think I've got it here. So this is, let me make this bigger, as big as I can make it. That didn't help. Let me make this bigger, as big as I can make it. Where's the big text button here? Here we go. Oh, come on. I know there's a way to do this. Oh, maybe it's Zoom. Yeah, zoom in and zoom out will do this. Okay. Yeah, that's getting better. Let's try that. One more. All right, here we go. So we've recharted this group a number of times. Our charter has always been tweaked a little bit as we perform this process. And the main ways in which we've done that this time are mostly included right in this paragraph here. So just for highlighting it, the scope of Bmwg has been extended to develop the methods for virtual network functions and their unique supporting infrastructure, such as SDN controllers and vSwitches. And this is a part of the charter which we basically took up as a work item last time, saying that we first had to fulfill getting agreement on a considerations draft, which we did. And then we went on to talk about the considerations for vSwitch benchmarking and got that approved. And now we're on the verge, actually, of fulfilling one of the other infrastructure method drafts, which is on SDN controllers. So we're clearly doing this, and now I want to be sure that we're looking at benchmarks for platform capacity and performance characteristics of virtual routers, firewalls, and other security functions, because that's being proposed. Signaling control gateways and other forms of gateways are included. The benchmarks will foster comparison between physical and virtual network functions and also cover unique features of network function virtualization systems. Also, with the emergence of virtualized test systems, specification for a test system calibration are also in scope. And I had a little discussion with one of our new folks here, Doug, during the week, which lines up very closely with this, Doug, I think. And I see Doug nodding. So we may get some new proposals right along these lines, and that would be good. So then the rest of the charter is pretty much as it's always been. Each recommendation will describe a class of network function and a set of metrics that aid in the description of those performance characteristics that we decide on our benchmarks. The set of relevant benchmarks will be developed with input from the community of users, and we're definitely going to do that. We could stand to do a little more outreach in that area at the various operator groups, but we'll ask that folks do that in the fullness of time. And we're distinguished from other initiatives in the IETF because we're characterization of these technologies in the lab environment, and that clearly allows us to do more than what folks can do on the production network. and we're striving for vendor independence and universal applicability to a given technology class. Demands of a particular technology may vary from deployment to deployment, so a specific non-goal of the working group is to define acceptance criteria or performance requirements. So it's there, and it's been there for actually a long time. I have to think of some different words there, but I think that's, I mean, we've always had zero loss as a criteria for RFC 2544 throughput. So it's a matter of expanding that correctly. And then provide a forum for development of advanced measurement techniques with insight from the operator communities. Okay. Any comments on the text of the charter? We've reviewed this on the mailing list several times. We have discussed it at the interim meeting and at the meeting in Singapore. I'm now asking for any final comments. Okay, we have one.
Where do you find this? I'm new, so.
Welcome, Doug. As a new person, you always say your name at the microphone
I'm sorry.
when you
Doug
first.
Brinkmeyer. Just curious where it is. I'd like to comment on it, but I want to read it.
Okay. Well, that's fine. I have sent it to the list in a message that I'm sure I can find a link for. It's if we make any comments today, I will be resending this text to the list, and it's possible that with our area director at the microphone, we may be making some changes right now.
No.
Okay.
Warren Kamari. So I fully agree with the last sentence. Ideally, Bmwg should be blah, blah, blah.
Right.
But do we think that that's very likely to happen? And if not, should we just drop it? It's true, but
I think we should continue to encourage it, and I almost had a chance to go to a NANOG meeting. I think it was last September, but it ended up. The reason I wanted to go was to get input that I could kind of deliver to the quick interim meeting that was taking place, and it turned out they were the same days. So I do have some intention at times to kind of try to follow through on what we talked about in getting this user feedback, and I think it also seats us very well in the operations directorate, given that we're looking for input from these organizations. So I don't want to lose that connection either. That really the benchmarking ought to be as much as we can. Driven by the community of users who are going to use the benchmarks. All right, let's talk about so here's one place where we're going to make some modifications, perhaps in the proposed milestones. And I look to Karsten here. I think, given the working group meeting in mid-July and area director review that could potentially follow that for a couple of weeks, by the time we get this to last call and IESG review, I'm thinking August 2018 is probably the more realistic deadline for this methodology for next generation firewall benchmarking. I see Karsten nodding, so that's good. So let's note the other milestones that we're proposing here. The update to 2544 back-to-back benchmarking. We saw a presentation on that today. Methodology for EVPN benchmarking. Saw a presentation on that today. We've got considerations for benchmarking network virtualization platforms. This is one we didn't see today, but for which there is an active draft. The network service layer models, and I said automated VNF benchmarking, Raphael. Is that a reasonable sort of a description for your GIM open source tool? And I mean, or maybe you'd like to edit the wording here a little bit. And please step to the mic if you would.
Rafael, I think it fits the current draft, but I think also we could make it a little bit more generic, because I think we can add automation, an automation as a consideration into the current draft, and as a consideration and a recommendation, and possible also as a reference for the open source code. Yeah, I would let the VNF benchmarking only if it's possible, to make it more generic, and the part of the automation would come together with it.
Okay, so just in general, so general VNF benchmarking, okay. So we have made some changes here. All right. And that's the last milestone that I'm proposing with this initial rechartering. Mr. Lynch. Oh, yes, let's go.
That's my dad, Pierre. Just a question. The test 09 work that's being done, since it's kind of positioned as an update to 2544 for virtual platforms, is there any intention to bring it back here?
Well, my thought on that is this. Our scope and we'll talk about this specification in a minute for those who are wondering. The background is that it's benchmarking for the NFVI, and I think a 2544 update ought to include not just the network virtual, the NFVI, but the world of physical and virtual. And so that's a bigger update which we're currently proceeding on. If you look back at our last 5 or 6 years of history, we've been updating RFC 2544 sort of a section at a time. And I think we ought to have an update in the future, near future, that pulls all of that together. It will pull in consideration from test 009 once we obtain agreement on that and share it with actually it's shared, all the drafts are shared with the world right now. So, but I think I'd like to take that up under the same scope, which is benchmarking for, infrastructure devices in the network in general.
Fair enough, I agree, but you don't want to stick it in here? It's not as one of the.
Well, we don't have an active draft on it.
So that is a requirement for one of these milestones.
I'm making that
Okay.
a requirement
Okay.
at this point. We can. What we need is a set of solid milestones that we can point to a draft and get this charter approved. We can discuss. We can have the rest of this discussion we just had. Once we get there. This has started, come on, man. This has started to happen in the latter half of the meeting here, and I wonder if it somehow, oh, look at that, there's a nice new island. This is a new Windows 10 machine, and I'm actually.
Can you send a screenshot for the minuting?
Yeah, sure. I'm absolutely astounded by the photography that they bring up. It's just beautiful. It's almost distracting from work. And so that's a good point. That at some point in the future, the 2544 update has to come. Carson.
I look forward to those extensive discussions. Anyway, I agree. It needs to happen. So one comment on this general VNF benchmarking. So if we substitute VNF by PNF, would this have any chance to have a draft on the general benchmarking for all physical functions, network functions out there? Routers, switches, fixed network devices, Bmwg, mobile core, IMS, anything that we can imagine in our world. Would you agree to have a draft on one standard that says it covers all? It doesn't make sense from my point of view. And only, actually the selection of vSwitch plus vIMS I have all respect for your work, but I think it does not belong in one draft. It's like to have an ice cream shop that also sells falafel. It
Yeah.
doesn't make sense, you know?
And Carsten, it's an excellent point, which I was sort of mulling over myself, and I think now that I think back to it, it was why I sort of inserted the word automated there as a possible distinguishing attribute of the work that Raphael and his team are approaching here. So I really resonate with the idea that you cannot write a single draft that includes all the relevant metrics for all the different PNFs and VNFs in the world and get all those metrics right and useful. I mean, that we have typically done that on a per technology basis. So how do we distinguish this milestone and make it worthwhile, make it something that you consider in the scope of your work, but not throw the but not make it a boil the ocean kind of milestone.
I think thanks for the comment. These were the kind of comments that I was willing to see here. And the idea, I mean, the initial idea of the draft, and it's open for reviews, of course, it's that we could make a ground foundation for different types of VNFs, and with a generic framework to address benchmarks in generic VNFs. I know that, of course, different types of VNFs have different metrics and different procedures, targets, and reports. I don't know how to put this, but automation is the fundamental part of the work, of course, and then also the running code. But the idea is to express generic procedures, generic considerations, generic setup, and other benchmarking methodology specifications like a VIMS or OpenDSwitch could come and address, based on these procedures, generic procedures of the generic VNF benchmarking methodology and the definition of the generic setup. There's a specific case for that where certain conditions were addressed, certain configurations, certain procedures, and certain target metrics were extracted. That was my initial idea, but I'm open for discussions about that. I understand it sounds vague, the general benchmarking, but it's up for the group.
So does this help at all to add automation, not as the first adjective, but kind of a follow-on? Does that sort of fit your goal?
I think so. For the purpose of following the charter of the group.
Yeah.
I agree. Yeah.
Karsten, you're thinking about it. Is there any way we can improve this that would help you? Okay. All right. Oh, right. Well, we can refine this, but let me ask the room. Any further comments on the text of the charter or the milestones as currently proposed? I feel like I guess I could ask for a hum. That's a reasonable thing to do. For the folks in the room, oh, come on, man. Who is this? Let's see. Oh, this is Sudin. All right. Sudin, I think we can hear you now. Go ahead.
Hi, Al. Could you please explain that you said benchmarking the network element?
I didn't hear the word.
Can you hear me now?
Yes, but the word, like something like network element. I didn't.
Yeah, you mentioned that rechartering to incorporate the network infrastructure.
Network infrastructure.
Correct.
Yes.
So
that's up here. The scope of Bmwg has been extended to develop methods for virtual network functions and their unique supporting infrastructure.
Okay. Does it involves the service provider infrastructure?
I missed the first part of what you said.
Sorry, Al. What I was mentioning is service provider infrastructure, whether it will include that.
Of course, of course.
Okay. Thank you, Al. Thanks a lot.
Yes, thank you. Sorry, I'm just missing a word here or there for some reason today.
No problem. Yeah, connection is a problem.
Thank you.
Yeah, thank you. Thanks a lot.
Doug, I'm wondering, in the second paragraph where you mentioned the new scope, should services be mentioned in there, or is it implied from the first paragraph?
Where would you insert it?
I don't know, I'm just assuming in these SDN networks, you want to test the services across them.
So one of the problems is that this terminology of network service has been a real mess. In ETSI NFV, they used it to mean something which no service provider would ever have agreed to, and yet somehow it got approved there. So I think it's just, the terminology is just too ambiguous to throw it down. Now we're going to have to tackle the problem a little bit in this network service layer abstract modeling. But I don't think I want to mess with this in the charter.
It's mentioned in the first paragraph. Is there a definition for it up there?
For network devices, systems, and services. Yeah, but I mean, there it could be anything like like TCP providing a reliable byte stream service to the layer above. You know, it's a more generic thing.
Right.
Maybe Warren has a clarification for us.
Yeah, Warren Kumari. So in general, people haven't really been paying that strict attention to the BMWG charter. Right? A document comes out and it kind of looks BMWG-ish, and everybody's like, okay, looks like a BMWG document.
Right.
So I don't really think that having it or not having it is going to change things. I don't think that, you know, if there were a services document, whatever that means, and it wasn't explicitly listed, anybody would say, no, you can't work on that. So I don't think it's worth the faff.
Good, thanks. Yeah. Okay, so I think we've had a decent discussion of this, especially the new text. So let me ask the group, I'm going to have 3 opportunities to hum. It should be mutually exclusive. You only hum in one of the 3 categories. There'll be a hum for support for the new charter, a hum if you object to the new charter, and a hum if you have no opinion whatsoever. All right. We'll start with the first one. Please hum now if you support and agree with the new charter. I hear some noise. Please hum if you object. Please hum if you have no opinion. All right, so what I heard there was support for the charter, no objections, and no abstentions. Thank you very much. All right, so we will, of course, ratify this on the list with the changes we made. Probably give about a week for comments, but we'll take care of that in the fullness of time. Thank you very much for your time on that. Very important step. So really quickly, in the last 12 minutes, we have a, oh, this will do. Yes, here we go. So we have a liaison from ETSI NFV, and it's on the specification with this tremendously long title. Specification of networking benchmarks and measurement methods for the NFVI, and that's network function virtualization infrastructure. So they're currently up to version 06 of this work, and it's coming from the ETSI NFV testing and open source working group, which our colleague with us today, Pierre Lynch, chairs. Thank you for joining us, Pierre. So the background is that obviously 2544 is quite old, can vote and drive in any state. And the demands for benchmarking have really grown a lot. And really the last 4 years, it's become exponentially important again. It's time to look at the specific problems for benchmarking in the NFVI and for a normative specification. We've started to write normative specifications in ETSI NFV, and this is one of them. So the idea is that consistency and repeatability are critical. So here's the table of contents with the topics that are most important flagged on the left here. We've got a general framework for benchmark definitions. It's kind of like the template we use in our definition documents. We go into great detail on the test setups and configuration, test device and function capabilities. So now here's where we're asking the vendors, here's some new capabilities we want. This is easy place for them to find that. Traffic generator receiver requirements and the general functional requirements. So we actually have two benchmarks in there on throughput and latency. Leaving the last meeting, we agreed to write benchmarks on packet delay variation, and that'll take 2 forms, and that'll be a new benchmark. And there's also going to be a benchmark on packet loss, just the classic measurement of loss ratio. So there's going to be at least 2 more benchmarks in this. In the methods of measurement section, we've got a great deal of detail to organize the hierarchy of testing, where a trial is like a single measurement under the test conditions. When you're seeking a goal, like the binary search we talked about, then you're going to run a series of trials within a test. If you repeat tests, then we have sets of tests. So that's the set hierarchy, which wasn't in your list, Raphael. And then we have a method above that. The method changes significant parameters for the lower levels of the hierarchy to examine, like frame size and protocols, encapsulations, things of that nature. So that's the hierarchy that we're working with in the methods of measurement. And what I probably should have said first, but it's worthwhile saying now, we started out this work in ETSI with a survey of the current benchmarking published results, the test campaigns, where people had learned a lot of things. And we put down the key learnings, and we talked about how we would address them in the document. And we've been working through all of these sections, looking for opportunities to address these issues as they've come up. So that's that's sort of the way this has worked. So the known issues, specification gaps, are search algorithms. And so here again, this is on my mind, so I was talking about it before, but we have to do a little better specification of this after we've talked about it some more. And we also need some sort of automated way to monitor the infrastructure. This is currently mentioned during benchmarking. And this is, for example, in OPNFV right now, we've got one of the daemons, collect D, that runs, and it can collect CPU utilization and some of the other platform metrics while the benchmarking is taking place. Of course, you have to test to be sure that your platform collection isn't influencing the results. So you have to rerun it without that. That's a form of calibration. And here's one of the tool gaps. We'd love to have automated collection software for the software and hardware configuration in all the meaningful dimensions. If we could pull that out of a platform and then make intelligent comparisons with that same information drawn from another platform, then we can easily see the differences and what might be significant to explain different results when we see them. And so that's kind of a holy grail that we need to fulfill. But we've identified that in this draft. And this picture that's impossible to see is a flow diagram that basically talks about this is the trial procedure over here, which feeds into the test and feeds into the sets and the methods and so forth. So that's that's basically what's going on with this draft. So that's a really quick look. But what I'm encouraging people to do in our community is to read this through, and also, let's not take up any overlapping work with this effort at the moment. Let us contribute to it. Let us take benefit from it, and then at some time in the future, when we're looking at updating RFC 2544, let's take what we've learned that's applicable to the entire universe of benchmarking and run that. So, any questions or comments on the liaison? None? All right. Well, ultimately, I think I'm going to set a date for comments, and let me simply make it 1 month. So, 1 month. And that's an action. Of a message to the list to set that. Because we've gone through this a couple of times. If we're not going to say anything, let's decide that. Very good. Okay. So the last item on the agenda here is, let me get rid of this one. Where's our agenda? Where's our agenda? Oh, way back here. Okay. Last item on the agenda is any other business? Any other business? Anybody thinking about doing some work in this world that they would like to tell us about for a few moments? Everybody signed the blue sheet? Good, thank you. All right, well, I thank all our remote participants while they can still hear us. I thank you all for participating today. And I'm declaring this session closed, which means now we can talk amongst ourselves about things that we were afraid to come to the microphone to talk about. Thanks, everybody. We'll see you in Montreal and on the list. Very good. Oh, let me put the times in real quick, which is real easy to do. Thank you. And I always like to, oh, thanks. I always like to, let's see, so this was 9:32, and it's now 11, okay, 56. There we go. Awesome. And it's 17. Thank you, Warren. The red button does not cause anything to explode. I used it when we had the Pac-Man show up in the queue over here. It was Sudin asking to make a comment. I have to press the button to allow him into the microphone so he can speak. So it basically promotes. It's a right. Oh yeah, they did a great job finding the equipment for that. Absolutely. So let's note takers. Let's get a screenshot of this before we lose it. That's right. That's right. We skipped 9. Yep. Let me get all this right now. Control C and.
So how are you related to UV? Oh, here or oh, I see. How does he have? Honestly, he's not my perspective. I don't recall. We write. My question is on ours. We use it. It sounds like whatever they're changing, it's more
Yeah, I think so. Is it this group?
Oh, that discusses that RFC? Absolutely, absolutely. This is the home of RFC 2544.
Well, it's making us hundreds of millions of homes.
Our first chairman, who was attending until 2 or 3 years ago, Scott Bradner, and the team of guys he worked with back in those days, they came up with 1242 and actually originally RFC 1944, which was updated to 2544 by Scott and Jim McQuaid.
And so 2544 is frames. Is there an equivalent in IETF for packets for like layer 3?
Well, it has always been used for both frames and packets. The only RFCs that concentrate on layer 2 and frames are 2889, the full mesh LAN switching RFC, and the terminology which goes with it, which is 27 something. I can't get it off the top of my head.
Like I deal with a lot of customers, and their big test is a speed test, right? A lot of them are using iPerf, which is not a standard. And then we use Y1730 for some of the stuff, and 1564.
Oh yeah. I had a hand in writing that.
Oh, did you?
Well. Yeah.
For sure, I mean,
So
1564 is better than.
that seems to be the one that everybody's kind of looking at now.
It takes off where people were trying to employ iPerf